Assalamualaikum. My name is Muhammad Afiq Nur Tapatamang. Today I will present about assignment 1 from Intelligent Control System Neural Network. Okay. We move to the problem statement. By using help of perceptron and other training algorithm, we have to construct our own classifier to solve the linear problem below 100% accuracy. The training sequence will be from top row to the bottom row. And then we have to retrieve the data by using help of perceptron and other linear algorithm by using a different training sequence. Perceptron and Hebbian. The Hebbian learning rule is a learning rule that specifies about how much weight of the connection between two units that should be increased or decreased in proportion to the product of their activation. For the weight is W nu equals to WO plus X times Y. Initially, the weight are set to 0. In example, W equal to 0 for all inputs is equal to I equals to 1, and then for N is the total number of the input neuron. The activation function for the input is generally set as an identity function. The activation function for the output is also set to Y equals to T. The weight adjustment and bias are adjusted to W nu equals to WO plus X times Y, which is repeated as I mentioned. And then the bias nu equals to bias O plus Y. The change of weight is delta W equals to X times Y, which also is same as weight nu equals to weight O plus delta weight. Next, I will talk about table of data Hebbian training. From the instruction given, we use Microsoft Excel to get this table, but before we use Microsoft Excel to get this table, we have to use MATLAB so that we can get a 3D graph from it, so that we don't insert any error value or we get any wrong answer from Microsoft Excel. Next is the 3D scatter plot, which can be seen that the left one is without the coordinate and the right one is with the coordinate. Moving to the next part is table of data Hebbian training retrained version, which is that we have been retrained. As we can see, is a bit different from the before retrained. For the graph of 3D scatter is also different. Okay, now I will talk about Adeline training program. An Adeline is a single neural model which uses a linear activation function. This method can be used instead of hard limited use by perceptron model or Hebbian model. Second point is implement logic or logic gate with Adeline. And then next part is step for Adeline training algorithm. First, need to step up a neural network model by initialize weight, which is W, bias equals to B, and set learning rate N, and the threshold. And the formula we can see is weight nu equals to weight O plus N kurungan T minus S X. For the set activation input is S, capital S equals to B plus X1 weight 1 plus X2 weight 2 plus X3 weight W3. For the update weight W and bias B, if an error occurred for this pattern, B nu, which is bias nu, equals to bias O plus N kurungan T minus S. And the last part is weight 1 equals to 1, weight 2 equals to 1, weight 3 equals to 1, bias equal to 0, and n equal to 0.5. Okay, this one is our table of data admin training instruction given without written yet, which we get also from Microsoft Excel. As usual, before we insert any data to get table like previous slide, we have to scatter a plot graph in MATLAB, which is the result we get is like this graph for the 3D scatter. For the next part is the table data of adrenaline training, which has been written. You can see a different version of it, which also can be same as the graph of 3D scatter plot from the MATLAB that has been written, which is different from the previous one. From the simulation, we can say that both adrenaline and Debian of Ceptron have few things in common, such as classifier for binary classification, linear boundary condition, and can learn sample by sample, and lastly, both use the threshold function. Despite both have a similar characteristic, they are also different between perceptron or Debian and adrenaline. Debian perceptron is learn class model coefficient if we use class labels. As for adrenaline, we use a continuous predicted value from the net input to learn class model coefficient, which is better since it will keep on updating its weights and will not stop if it cannot categorize or recognize the input vector. As the conclusion, we managed to learn about both learning type, about their strength, and therefore their advantages and disadvantages. But if we compare between Debian perceptron and adrenaline is a better learning program since it will keep on updating if there is an error at the input. With that, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraj Binti Muhammad and my matric number is AE170061. So, based on the assignment given, we have to choose between Debian and Perceptron and add the lunch training algorithm and retrain the data. So, in this case, I use Debian training algorithm, and this is the data given. They split into two classes, class A and class B. This is the table. So I using learning rate is equal to 0.5. So the value of t we need to determine by ourselves. Same goes to this blue region, which is the oldest value of W1, W2, W3, and bias. Next is after I run a few tests, we will have the value of y1 is equals to -1, the value of y2 w2 equals to 2, the value of w3 equals to 1.5, and the value of p is equals to 3. So in this table, we try to run a few tests. When the value of x1 is equal to 0, the value of x2 equals to 1, and the value of x3 is equals to 1, we got the t equals to 1. So 2 plus 1.5 is 3.5, right? So the t is meaning that it fired. The t meaning the t is we have to type, right? 0 and 1. So 0 mean not fired and 1 is fired. So meaning here when the value is more than theta 1, this here, it will fire. So in this case we have 3.5 is more than 1. Therefore t is 1. So the y prime indicates that the value of t is correct. So she's correct. Same goes to the other data. We try another one. So we have this one, x1, 1, x2, 1, and x3 equals to 0, 1, and the t is 1. So we have -1 plus 2 plus 0 since the x3 is 0, right? So when negative 1 plus 2 is equals to 1 and the theta is 1. So when the value is more and equal to 1, we will assume the t equals to 1. Therefore, we have gained the y prime is 1. So in this table, we can see that the t and the y prime is the same. So the accuracy is 100%. Therefore, after that, we create an equation based on this equation to create a straight line. So we have x1 w1 plus x2 w2 plus x3 w3 plus b equals to theta 1, which is from here. So key in the value of w1, w2, w3 and bias. We have x3 equals to negative 4 plus 2x1 negative 4x2 equals to 3. After that, since we have three variables, we assume ourselves the value of x1 and x2 to gain the value of x3. Next, we run this data. Next, we will run this coding to gain the graph. So this is the graph we gain from the coding. So we can see here we have a straight line and 6 data. However, based on the table here is we are supposed to have 2 data at this region and 4 data at this region. But however, we only have 1 data which is here. So we can conclude that the graph for the accuracy for this graph are not that accurate. The value of this graph are not that accurate. So to obtain more correct data, we need to change the value of W1, W2, W3B, the blue regions to obtain uh, obtain the data of the graph.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Farhana binti Satosa. My metric number BEH41803. Okay, for this part, I will explain about the underline training rule, top to bottom. For first, this is the data that are given from the instruction. Okay, for this, we are using the learning rate, which is 0.5. And we are assume W1, W2, W3, and B 1, 1, 1, and 0. Okay, this is the data of x1, x2, and x3. We divide by two class, which is this is class A and this is class B. Okay, this is S. How to get the S? We are using this formula x1 times W1 times x2 x1 times W1 plus x2 times W2 plus x3 times W3 plus B. We got the value of S. This is the value that we are assume 0, 0, 0, 1, 1, 1. This is the value of Y, which is T minus S. We got this value 0, negative 1, negative 1, negative 1, 1, and 0. This is the value of read new. To get the value read new, we are using this formula WO plus N times xi times t minus s. We are repeated from the equation to get all this value for W1, W2, W3. For the bias new, we using this formula BO plus N times t minus s. Okay, this is with sum. Since x1 multiple times w1 plus x2 times w2 plus x3 times w3 plus b, before that the value of w1, w2, w3 and b we are using this value 1, 1, 0, negative 0.6, and we are got the weight sum value out of this by using this equation. This is y prime. Y prime is same with t to get the 100% accuracy. This is the value of theta. The weight sums is much bigger than theta. Y equal 1 and S is 0. Range for theta that we are got is negative 0.63 between 1.5, and we assume the theta is the 1.05. Assume threshold we are using 0.5. Okay, this is the table x1, x2, and x3 to get the straight line for the graph 3D scatter plot. We are assume x1 and x3 to get the value of x2, and we are using this equation, and the final equation we got x2 equal 1.65 minus x1, and then this is value that we are got. Okay, I will show you the how we are find the graph from the MATLAB software. The coding that are we using in the MATLAB software. Okay, x, y, and z is the meaning is x1, x2, and x3. Okay, this is the graph 3D scatter plot that we are got, and this is the straight line from the table x1 and x2. We are got the value, and this is the coordinate of x1 and x2 and x3. 111, 1110, 010, 101, 001, and 000. Okay, I will continue the Adelaide training rule by retrain. Okay, from the table data this, we are retrain the data x1, x2, and x3, and the value of 3, which is 1, 1, 1, 0, 1, 0. Okay, to get the new value after we train for S, we are using the same equation from the above, x1 times w1 plus x2 times w2 plus x3 times w3 plus b. And we got this value for S21, 1.5, negative 0.5, 0.5, negative 0.25. This is the value of t minus s, which is value of y. We got this value, and the value w1, w2, w3, and b, we are still using the same value that we are assumed, which is 1, 1, 1, 0. This is the value of with new. We are still using the same equation 2, which are w0 wo plus n times xi plus times t minus s. For the b, still 2, using the same equation. For the b new equal bo plus n times t minus s. For the weight sum, we are, since x1 times w1 plus x2 times w2 plus x3 times w3 plus b, and before that, the value of w1, w2, w3, and b, we are using the value this 0.25, 0, 0.5, negative 0, 1, negative 0.125. Sorry, this is the value of y prime. Y prime is same with the value of t to get the 100% accuracy. I got for the y prime is 111,010. Is this same? Theta, the range for theta we got is 0.5 between 1.5, and we assume the value of theta is 1. Okay, this is the table for to get the straight line for the graph 3D scatter plot. We are assume x1 and x3. To get the value of x2, we are using this equation, and the final equation we got x2 equal 1.125 minus 0.25 times x1 and minus 0.5 times x3, and we got the value of x2. And this is the graph for 3D scatter plot that we are using the MATLAB software. I will show you too how to find the graph from the MATLAB software. Okay, this is the graph 3D scatter plot that we got from the MATLAB software by using these codings. Okay, this is the straight line that we got, and this is the coordinate for x1, x2, and x3, which is this is the 111, 110, 010, 101, 0001, and lastly 000. That's all. Thank you from me.